Okay, ladies and gents, this is 2.1, average and instantaneous rate of change. So let's just start. This right here is the formula to find instantaneous rate of change. So basically this means that's that's f of b, that's 1 point, and f of a is another point, and you subtract the second point by the first point, and then it'll equal your instantaneous rate of change, right? So for example, right here, plugged in the numbers 1 and 4, right? And you could see where I used the formula. 4 and 4 always stay together, and then 1 and 1 always stay together, right? And then from there you can see where I got my answer. And then even on this one, on a chart, it's the same thing, except like this is a group, this is a group, this is a group, and so on, right? So find the average rate of the interval 2 to 30, right? So from 2 and then to 30, right? So 30 stay together, and then 2 stay together, and plug it in right here, and that's my answer, right? And actually, oh, never mind. I thought that could simplify more for a second, but it cannot. If it was a 27, it could, but it's not, right? So this is the following quotients express the average rate of change of a function over an interval. So the important part here is this. This is also the slope of a secant line, right? So, and then right here, the following limits express the instantaneous rate of change of a function at x equals a. So this important right here, this is also the slope of a tangent, right? This is the important part. And so then we go next page and we can work this out. So find the instantaneous rate of change of f of x equals x minus x squared at x equals -1, right? So you could see where I put f and h, f of a and f of h, and separate them. And then from here I can plug in the 1, which is what I do right here, and then find as h approaches 0, and then it turns into this big old equation, but that's kind of ugly, but it simplifies down, obviously, right? And then you can see where and then from here it just simplifies down more, and then it turns all the way over here where the limit as h approaches 0 is 3, right? So yeah, and then even right here, identify the function we are working with and identify the value of the instantaneous rate of change. So right here, the function right here is the 5 log, and then the 2 over x, because of this 1/2 makes it 2 over x, right? And the instantaneous rate at x is equal to 4, because you just plug it in, right? And then this one is a little bit more complicated, but because of sine x minus 1, the function is just sine x, right? And then the instantaneous rate of change is pi over 2 because of this pi over 2. And yeah.